Here are three of the major ice core projects in Greenland. The Neem Ice Core is located in northwest Greenland near Thule and stands for the North Greenland Eemian Ice Drilling. It is an international ice core research project managed by the Center for Ice and Climate in Denmark. GRIP stands for the Greenland Ice Core Project and is located in east-central Greenland. It was organized through the European Science Foundation. GRIP drilled a 3-kilometer deep ice core to the rock under the Greenland ice sheet at Summit, Greenland from 1989 to 1992. GISP-2 was the second attempt at the Greenland ice sheet project. It is located in central Greenland and is slightly deeper than GRIP, currently one of the deepest ice cores in the world. This project was funded by Denmark, Switzerland, and the United States.
When snow falls, young snow buries older snow and causes small air pockets to be trapped. As the weight of overlying snow increases, the loose snow turns into granular snow and then into a material called firn. Eventually, with even more pressure, the firn transforms into a solid mass of ice. This ice can be composed of up to 20% air trapped in tiny bubbles within the ice.
Alright, today we're going to look at an ice core from Summit, Greenland. So the first thing we're going to do is line it up on this light table here, which will allow us to see the different layers within the ice core. By looking at the concentrations of the gases within these air pockets, we can get an idea of what the atmosphere was like back in time.
Here we can see the difference between a summer layer and a winter layer, and the little black dots represent air bubbles.
So looking back in time, counting from the top of the core down to the base, it's actually looking back into history, and by counting the layers, we can figure out how old the ice core is.
I'm sitting with Ali Beatty, a graduate student in the glaciology program. So, Ali, what kind of information do we get out of ice cores?
So there's three types of information we can get from ice cores. The first is from the bubbles in the ice. And trapped in the bubbles are gases from the atmosphere at the time that the ice was frozen. So we can get concentrations of gases like carbon dioxide and methane, which are tied to changes in temperature. So changes in carbon dioxide will tell us something about the changes in temperature over time. The next thing we can get out from ice cores is we can look at the material that's been trapped in the ice itself. So we look at something like dust, for example, which would tell us about the wind direction. The final thing we can get from ice cores is by looking at the ice or the frozen water itself. So by looking at the actual hydrogen and oxygen atoms, we can in fact reconstruct temperature at the time that the snow forming the ice fell on the ice sheet.
How exactly do we get this information out of the ice cores?
So it's really fascinating how we can get this information from the ice cores. In the case of getting information about the past atmosphere from the air bubbles, what scientists do is they crush up that ice, and then the air that's released from the bubbles will then be the only air in that container. And that's how we can isolate the air from 50,000 years ago and analyze it, like I said, for its carbon dioxide concentration, its methane concentration, and other such gases.
Scientists from around the world come to Greenland to drill ice cores. Ice cores contain information about past climates. The deepest ice cores contain ice 110,000 years old. Greenland and Antarctica are the only places in the world with ice this old.